Science. I'm Sarah. We're going to be talking a bit about climate change and the greenhouse effect today. We're going to keep it pretty basic and just kind of talk about some key molecules that are making this happen. And then Marin's going to come and she's going to tell us a few things that we can do to lower our carbon footprint, okay? So, first of all, what is the greenhouse effect? What is it? So, we're going to look at this diagram and hopefully you can see it in an all-right fashion. When we're looking at Earth, we have our atmosphere on the outside, and it kind of acts as a safety bubble around the Earth so that we are not burned to a crisp by the sun's rays and radiation. So normally what would happen would be this middle diagram right here. A portion of the sun's rays would come in to the Earth, and they will bounce off of the Earth and come back out and exit the atmosphere. Things that are bouncing are polar ice caps, bounce off a lot of heat back out into the atmosphere. Places like the ocean are going to be absorbing heat, even though the ocean on the whole is pretty cold. A lot of that heat is going to be taken out on the equator, but not all of it is absorbed in, and not all of it is kept in. Some of it is pushed back out. So there is a balance there. With the greenhouse effect, we have an increase of atmospheric gases that are kind of in between this outer layer and the Earth, which are trapping these rays into the atmosphere and keeping them close to Earth rather than releasing them back out into space. So what happens is these sun rays come in and they're bounce, and staying inside and warming our atmosphere. Another issue that we have, which is a little bit separate from the greenhouse effect, is sometimes we burn holes in our atmosphere, or we burn holes in the ozone. And so what is happening here is the sun's rays are not really being regulated as they come into our atmosphere, and we're getting more than we bargained for, and that's a problem too. Because if we're burning the ozone, then we're burning our safety net, our safety bubble around the Earth. So that is kind of how the greenhouse effect works. We're trapping in gases that would otherwise be bounced back out into space. So let's talk about some of the molecules that are helping do this. So first is water. And water is important not because water is bad for the environment by any means. Water is life, but it is a strong regulatory factor in looking at greenhouse gases and climate change. There is a lot that is taken up into the atmosphere as precipitation happens and evaporation through the water cycle. And so some of these molecules are kind of riding that wave, and water is a huge regulator to that. If there's not rain, if there's not snow, and all of these things, we're not going to be having the bounce back that we need to push things back out of our atmosphere. Nitrous oxide is commonly used in fertilizers and in agriculture. And yes, so that is what's going on here. When we're using these products in excess, we're putting out nitrous oxide into our atmosphere. The next one that we hear a lot of is methane. This has been something that's been of great debate, especially with conversations of the Green New Deal. Methane is a big deal in looking at that. Methane is very organic. It is going to be in agriculture. It is going to be from decomposition, landfills, pretty much the entire cow and pig industry. Lots of conversations about methane. Methane is a very strong molecule in our atmosphere that does do a lot of damage. Carbon dioxide is one where humans are extremely responsible for its use. We don't have any data about climate change before the Industrial Revolution. That's kind of when scientists are able to notice a marketable change, because this is when the Industrial Revolution begins. We're going to start using mechanisms, mechanizing. We're going to be using gas, fossil fuels, coal. We can mark in time how that's changed the environment. Carbon dioxide usage has increased 47% since the Industrial Revolution. So that doesn't include the jump from not even being industrialized at all. And so when we're talking about this, we're talking about coal, we're talking about fossil fuels, and pretty much everything else. Pretty much everything that we use uses carbon dioxide. Lastly, we have our chlorofluorocarbons. Never heard that word, I'll say it again, chlorofluorocarbons. Or CFCs is another way that they're written down if you're reading papers. Chlorofluorocarbons are not organic, even though the word carbon is in it. It is not really a naturally occurring thing in the environment. It is completely industrialized and completely human-made. And it is extremely dangerous to our ozone. This is one of those things when we talk about burning holes in the atmosphere, we talk about chlorofluorocarbons. These are they're very tough. So they're highly regulated by the government, highly regulated, and so some of the main things that they were in when they first came out was like gasoline, hairspray, just about most random things, but they were being consumed at a high volume. So what happens due to this? We have an increased temperature in the world. And so this, in some ways, some people will push back and say global warming is not that bad because it's going to increase agriculture. In some places, yes. In some places that agriculture has never been good before, it will be good. But in places that we thoroughly rely on, it will be either very dry or overly wet. It's going to change the entire shift in the way that we do agriculture. So it says more precipitation, more evaporation, and an increased temperature. We talk a lot about melting ice and raising water that would never be in those kinds of areas. I think we would have a lot of land coverage over New York and much of Los Angeles in those cases. High atmospheric carbon, like I said, could increase plant growth in places that it's never been, burns the ozone, and changes our temperature. There are so many effects, there are so many documentaries, there are so many things coming out more and more all the time about climate change. So watch some films, see what you can see, read some data. There's new data all the time, and there's really great federal data coming out from NASA and from the National Science Foundation that is readily available. So we're gonna pass the time to Marin for our activity this week. Thanks, you guys.
All right, guys, so for our activity this week about climate change, we have a couple of different things that we can do. First things first, we're gonna run another experiment. Similar to one that we did a couple of weeks ago, how we we had methods and a hypothesis and things like that. So what you're gonna do is you're gonna take 2 glass jars, you're gonna fill them both up with cold water and put the same number of ice cubes in each one, okay? So we have some nice cold water. Then over one of them, you're going to put some plastic wrap or a plastic bag and secure it in place with like a rubber band or a hair tie, okay? And then you're gonna put them out in the sun. Now, even if they're out in the sun when it is cold outside, as long as it is not below freezing, this should still work. So you can still do this while it's a little bit chilly outside. Basically what's gonna happen is you're going to leave them out in the sun for a couple of hours, and then go and take the temperature of each of the waters and see which one is at a higher temperature. You could even do it multiple times, like one after 1 hour, and then take the temperature again after 2 hours, 3 hours, things like that. And that will kind of help model the greenhouse effect. And the reason that it's called that is because it happens in greenhouses. We have the glass that is keeping all of the heat inside, so the rays of light can penetrate in through the glass, but then the heat cannot escape through it, which makes it hotter inside, which is very beneficial to greenhouses themselves. But when you're looking at an entire planet, like Sarah explained, that can be a bit of a problem. Now, ways that you can help with these kinds of things. First things first, don't give up hope, right? You know, this can sound really scary and very intimidating, but there are still things that you can do that can help other people and help the environment, okay? So here are some big things you can do. You can reduce how much meat you're eating. You can encourage your family to try meatless Mondays or to only eat meat at dinner time or things like that. So reducing the amount of meat that you eat is a big one. You can eat local. So a lot of the food that you get, even if it's organic food, if it's having to be shipped in from lots of different places, then it is using more carbon dioxide overall. So it's good to try. You can go to the farmer's market, you can plant your own garden, which I have right here, planting trees and garden, or just asking your grocers, or if you go to restaurants, you can ask them, where do you get your food from? And that'll also let the people who run those places know that there are people who are interested in having locally sourced food available, okay? Like I said, to plant trees and to garden. So planting plants can help minimize the effects since they do take in carbon dioxide and release oxygen. Those are things that can kind of help clean things up. A major one for this too, what's really cool is actually algae. Algae is a huge one. They produce so much more oxygen and take in so much more carbon dioxide than any of the ones that we are familiar with. So even though, you know, planting trees and gardening will absolutely help, just remember that sometimes some of the things that we disregard as unimportant, like algae, might actually be really, really helpful. And the last thing is to stay informed. So this is a good way, watching videos like this, watching documentaries like Sarah suggested, and figuring out what you can do and what you can tell others to do to help the earth and help with climate change. That is the most important thing, is once we're all informed and we're all in it together, then we are more likely to be able to reverse the effects that are happening. So get out there, look up some more information, try some of these things, try the greenhouse experiment, see what you find, and we'll see you guys next week.